what is the frequency in hertz of the second resonance for a one-end closed tube that has a height of 15 centimeters, knowing that the speed of sound is 343. Okay, they are asking about now, what is the frequency of what? Of the second resonance. And this is the most important word here in this question. Second resonance. Okay, then what is the second important word? Is it closed or open tubes? It is what? Closed. So that means this is now the second important word. Okay, now, as we know, for closed tubes, as we know, closed tubes, the first resonance goes when the length of the tube equals what? Quarter lambda. While in the second one here, as we know, it's gonna be what? 3/4 what? Lambda. 3/4 of lambda. So that means here, the second resonance, it's gonna be what? The length of the tube will be what? 3/4 of what? Of lambda. Why? Because we said you start in closed tubes. We said in the introduction view, you start for the first resonance of closed tubes at the length which is what? Quarter lambda. Then for the second one, you add half a lambda. So that means you add 2/4. You add 2/4 for this one. You add 2/4, it's gonna be 3/4. Then you add 2/4, you're gonna get here in the third one, it's gonna be what? 5/4 what? Lambda, and so on. So that means this one is quarter of a lambda, and here is what? Here this is quarter and this is half. So that means you get here what? Quarter here and half lambda here. So that means it's gonna be what? 3/4. The length of the tube, that means the length from here to here for the second resonance is 3/4 what? Lambda. So now on the question, are they asking about the second resonance? Yes, they are talking about the second resonance. So that means they are talking exactly about this idea here. And now I know that the length equals what? The length of the tube equals 3/4 lambda. Now see the question now. They gave you the height, and the height of it means the length. They gave us what? The length. And they gave us here what? The velocity. Okay, the velocity is given. And they are asking about what? The frequency. Okay, what frequency that links these ideas here? It is the main formula that velocity equals lambda times frequency. So this is now the main formula here. So what they gave us here, as you see, they gave us the velocity, and they are asking about what? The frequency. But they didn't give us what? Lambda. So we need to find lambda. How can we find lambda now? From this formula, from this one, which is the length equal. So now we go length equal, as long as it is for the second resonance, we use this one. If it is for the first resonance, we use this one on the left. If it is for the third, we use this one, as long as it is closed tubes. If it is open tubes, you use the formulas that are related to what? To open tubes. So here now length equals 3/4 of what? Of lambda. Now what is the length here? It's given for us. It's 15 centimeters. And 15 centimeters is not in the unit of length. So that means you need to change it into meters. So we divide by 100, we'll get 0.15 meters. So that means this one now is the length. We substitute the length here. So what will we get here? 0.15 equals 3/4 what? Lambda. Now we solve as math to find what is lambda. So we need to get rid of 3/4. So we multiply by the inverse, which is 4/3. And you multiply also the other side by 4 over what? Over 3. What will happen in this case? As you see, 3 will go by 3, 4 will go by 4. So that means lambda is left. And here now, 4/3 times 0.15. Okay, here the denominator is 1. If you multiply now 4 times 0.15, you will get 0.60 over what? Over 3. So now lambda equals 0.60 over 3, you will get 0.20. So now here I reached what is lambda. When I get now what is lambda, I substitute the lambda here. Now, how many variables I have now? I have the v, which is the velocity, and I have the lambda. Now I can find f easily. Now you go here, so velocity again, velocity here equals lambda times f. Now what is the velocity? It is 3, 4, 3 equals lambda. We didn't know what, yeah, we know what is lambda here. So lambda is 0.20. 0.20 or 0.2, it's the same. So you can write in 0.2 times what? Times f. Now how can we find f? We divide both sides by 0.2 to get rid of what? Of 0.2. So 0.2 here will go by 0.2. So that means what is left is just the frequency equals here. For the other side now, it is 343 over 0.2. What do we need to get rid of the decimal? We multiply both sides up and down by what? By 5. Why I choose 5? Because when I multiply 0.2 by 5, I get 1. That's it. So that means the denominator now will become 1. Now the numerator will become what? How can I multiply the numerator easily? When I multiply this one by 5, 343 by 5, I multiply the 5 by 300, I'll get 1000 what? 500. Now I multiply the 5 by 40, I'll get what? 200. Now I multiply the 5 by 3, I'll get what? 15. So that means now I got 1,500 and 200, 1,715. So that means I'll get 1,700 what? 15. 1,715 over 1, it's gonna be what? 1,715. And what's unit of frequency is what? Is hertz. So that means this is the answer now, 1,715. You go to choose on the question here 1,715 as the answer.